Trying to spray paint your game day banner, but you just can't shake the can? Have you been shaking for hours, but still no paint is coming out? Shaking a spray paint can be frustrating and tiring on your wrist, but it doesn't have to be.
Hi, Ryan Irwin here, and I would like to introduce you to the CanShaker. The CanShaker makes shaking a spray paint can as easy as turning a handle, reducing the need for handheld shaking, which can quickly tire out your arms. The CanShaker makes spray paint projects a breeze and allows you to use many different colors and kinds of spray paint without having to spend long periods of time shaking various cans of spray paint. Don't let shaking the spray paint can be a barrier to any of those home improvement projects you've been putting off. Allow the CanShaker to make painting a breeze.
In order to achieve optimal mixing of the paint, the can needs to be shaken fast, which is often tiring on the arms after long periods of shaking. The shaker is designed with a belt ratio, which allows the can to shake 3 times for every turn of the handle, making this shaking process much easier for the user. Simply shaking up and down isn't enough for optimal mixing. Shaking side to side allows for full mixing of the paint. That's why the CanShaker shakes not only up and down, but also rotates side to side, making mixing quick and convenient. The CanShaker is the result of extensive analysis and optimized gear ratios. Previous models had too high gear ratios, causing the belts to slip and the mechanism to bind up. A ratio too large makes the cranking of the handle difficult and can lead to breakage. As seen here, a ratio too small leads to shaking too slow, requiring the user to crank faster to achieve the same shaking speed. The ratio on this model is optimized to allow the user to achieve a good shaking speed without needing to turn the handle too fast. The CanShaker is also designed to limit belt slippage and reduce the forces on the frame to minimize the potential for breaking. The components for the CanShaker are designed in SolidWorks. The first step is drawing the base. The base has holes for each of the drive shafts to fit through, as well as slots which the carriage will move within. One of the slots is angled to cause the carriage to rotate in addition to cycling up and down. The base will be duplicated and used on either side to make up the frame. The next step is to design the main drive shaft. This will be attached to the larger belt wheels as well as the handle. The next step is to design the follower drive shaft. This will be what links the belt wheels to the crank, which moves the carriage up and down. After the follower drive shaft is attached, the follower wheels, which will be attached to the belt, will be designed. These have 2 larger outside discs with a smaller disc in between, forming a slot the belt will fit into. The final step is to design the cranks and links, which move the carriage up and down with the revolution of the follower drive shaft. The links will be connected to the top of the carriage. The large wheels are then designed similarly to the small ones, with a slot for the belt to fit into. Finally, the carriage is drawn and attached to the links. The handle is then drawn and attached to the outside of the large wheel. The CanShaker can be built right in your very own home. The first step is to draw out all the pieces that need to be cut out onto sheets of plywood. Using measuring tools is important, otherwise the pieces will not fit together properly. Once the outlines are drawn for the base and circular components, the pieces can be cut out using a jigsaw. Take your time, as making sure the lines are straight and precise is very important. Once the pieces are cut out, the holes for screws and drive shaft components can be drilled out. Planning and drilling precisely is important, otherwise the shaft will wobble. Since the carriage holding the can will need to slide through the slots, it is important to make sure they are smooth and free of bumps. Straight lines are difficult to create using a jigsaw, so it's important to smooth out any accidental bumps using a rotary tool. Once the slots are straight, they can be sanded smooth to reduce the friction between the carriage and the base to allow for smooth motion and function. Continue testing the slots with a dowel until it moves with little to no resistance. The circular pieces of the wheels are then assembled by nailing and gluing the pieces together. The next part is to assemble the drive shafts. The drive shafts are made up of many different sized pieces, so precision is especially important here. The first step is to cut the necessary pieces to length using a saw. In order to drive the metal rod through the center of the drive shaft components, It is important to identify the exact center of each of the pieces so they can be linked axially. Drilling the components down the center is especially important, and taking time to make sure the holes are straight down the center is essential to smooth function. Once the drive shafts and wheels are connected together, it is important to Dremel down the nails still protruding. This is done for safety reasons, as well as ensuring nothing is caught or hung up on the wheels during operation. Once all the pieces are drilled and cut, they can be put together. Glue is recommended as it keeps all the pieces together. It is important to be careful not to twist or break any parts while putting together the components. Once assembly is completed, it may be necessary to cut out larger pieces of cardboard to place on the outside of the belt wheels to prevent the belt from slipping off during assembly. Belts are the final component added to the shaker and should not be attached before all the other pieces are assembled. Once the CanShaker is assembled, you can test it out for yourself. To improve the function of the CanShaker, the manufacturing processes can be refined to be more precise. Using lathes, drill presses, and metal instead of wood will reduce the inconsistencies within this model. Using a lathe will allow the holes drilled to assemble the drive shafts to be centered and straight through the axes of these components. Ensuring the drive shafts are straight and have no play or wobble will allow smoother function and less friction. The CanShaker is designed to operate with a user input of 1 turn of the handle per second. This results in the can of paint going through an up-down cycle 3 times per second. The can has a maximum speed of 667.5 inches per second in the middle of its cycle and an angular velocity of 74.2 degrees per second. A force applied perpendicular to the handle of 15 pounds results in a force of 10.01 pounds needed to hold the can stationary, providing a mechanical advantage of 1.69.